Amit Bando, we'll start with you. You are Executive Director of the International Partnership for Energy Efficiency Cooperation Secretariat. So we have seen in the poll what people think of energy efficiency. Do you think that energy efficiency is a priority for governments, an international priority? But perhaps first of all, you can talk about what IPEE is doing. Okay.
Thank you, and good morning, everyone. Yes, as was discussed earlier, I think energy efficiency plays an important role in any kind of decision-making process in this area. And so with that in mind, IPEC, or the International Partnership on Energy Efficiency Cooperation, was established late 2009 as a result of a G8, G20 initiative. And we are 15 member countries voluntarily coming together with the idea that if we are to do something, we ought to do something in a collaborative and in a way that is inclusive. So not only does it mean that these member countries are interested and involved and voluntarily agree to do something on energy efficiency issues, but it also means that there is a potential to reach out to the private sector, clearly understanding that policies and programs and actions taken simply by governments, no matter how inclusive they are, is not going to work, because most of the technology, if not all, is going to be driven by the private sector. And as was mentioned earlier, with 50% potentially of all of the actions that are doable, being in the energy efficiency area, there's obviously an important role to be played here. So that's really the context with which energy efficiency is placed within IPEC. And the idea here is to facilitate implementation of energy efficiency programs worldwide. So often what we do is we try to really look at starting with the basic concept. As we just saw earlier, there may be skeptics about who's causing climate change and what's happening, but we can all agree that there are many things that can be done to improve energy efficiency. Not just reduce energy intensity, which is the energy per unit of production. That can simply be done by lowering activities, if you may, as was mentioned earlier. If you move from energy-intensive industries such as steel or cement or whatever, and move to more service-oriented industry, you can go ahead and reduce energy consumption. That's not the purpose here. The purpose is to say that how do we do it on a technology by technology basis. So often what we need to do is to define what is the energy efficiency potential. And so I'd like to just quickly summarize the fact that you can have a technical potential, which means that you have a lot of things that you can do. However, once you start looking at the economic costs of implementing something, then you're reducing the number of options. From there, you go to the fact that often these markets that we talk about, these energy efficiency technologies and options, are new. Markets do not exist. Prices do not exist. There are not enough incentives. There's not enough of a scale-up, if you may, where consumers are aware. As a result, there are many market adoption barriers. So if you look at the yellow bars, they're shrinking as we include all of these different feasibility options, going from technology to including only those that are economically feasible, to those that are only achievable once you overcome the market barriers. Finally, looking at things such as program barriers, staffing barriers, knowledge, so forth. You're really recognizing that these options tend to shrink. So that's where we get to the point that at a very broad level, people talk about energy efficiency being a low-hanging fruit. You hear that all the time. But when it actually comes down to implementing and facilitating and going forward with energy efficiency measures, you have a much lower set of options, and that's kind of what we're trying to examine and facilitate improvement on.
Thank you. Rémi Chabrillat, vous êtes directeur production et énergie durable de l'ADEME, et on vient d'entendre que c'est un niveau international politique, c'est peut-être l'énergie, l'efficacité énergétique, c'est pas un sujet qui est traité en priorité en France. On va parler de la France. Maintenant, vous avez travaillé sur les projections de la consommation de l'énergie jusqu'à l'horizon 2030. Oui. Qu'est-ce qu'il faut retenir de ça, de ce travail?
Merci. Bonjour. Good morning, everyone. I'll try it in English. The first thing on the situation. We focused on 4 sectors, or 3 and 1. The first is buildings. Buildings is about 44% of energy consumption in France. And what we have to think about is that existing building is the more important. The stock renews 1% a year. An existing building will last 1 century, and we can't wait 1 century to work on energy consumption on this stock. So there's an important part that will concern improvement of existing building. The second target is transport, and on this one there are 3 ways. The first is to work on the need of transport, and it's a matter of city planning mainly, and it's quite a long-term action. The second is to use non-energy or lower energy consuming transport modes, public transport first, but also cycling, walking, and so on. The third is to improve fuel efficiency of classic petrol-fueled vehicles. You've heard maybe of a government objective that has been announced lately, and it's about motor using 2 liters of fuel for 100 kilometers. I say 3, and there's a 4th one. The 4th is decarbonization of transport by using other fuels, electricity, hydrogen, maybe biofuels. That's one thing. The third sector, but I think we'll talk a little more about it later, is industry, where a lot of things have already been done, and that's you can see on the scheme that that's the sector that reduced a lot its consumptions in the last 40 years, but a lot of things can still be done. And I said 3 plus 1, a little one is agriculture. Agriculture is not a big problem for energy in France, but first, energy can be a problem for agriculture. Some branches of agriculture have a level of energy consumption that can represent 25% of their costs. And also, if we think about greenhouse gases, agriculture has a large part in the emissions. Just to end, the work that we're doing for 2030 is still work in progress, but we estimate that being both ambitious and reasonable, we can reach an energy consumption reductions of about 20% for the whole field, and it means about 31%, excuse me, of reduction of energy consumption in buildings, 23% in transport, and 10% in industry. That's what we are going to propose.
Okay, so Amit, Bando, do you agree with the French priorities, or from your point of view, what should be done by 2030 to be more energy efficient? In which area we can achieve good results?
No, I think the priorities are in fact exactly on target, and just to expand on that a little bit, as was mentioned, buildings are very high in terms of the potential. And if you really go beyond this to the emerging economies, we talked about China in the morning, our membership includes China, Russia, India, Mexico, Brazil. If you look at the building stock and project out 20 years from now, 65% of the building stock is not yet built. So in addition to the old buildings existing in countries such as France and the US, I think that's an important number to look at. And if you then think about the fact that there is a tremendous potential, not just looking at it from a sector-wise perspective, but looking at it from an integrated way, where you look at what some people talk about smart cities. The idea of integrating buildings with transportation, urban planning, looking at issues such as smart metering, such that energy delivered can be monitored and delivered in such a way that you can take advantage of the fact that during peak periods you increase the price maybe and induce consumers and cause behavioral change so that there is more usage during low periods and so that you have a more evening out of the supply. Now, technology exists for all of this. The idea is to then have somewhat of a creative approach where instead of thinking about sectors in isolation, you think about an integrated approach, a planning such that there's use of technology within a new paradigm that causes behavioral change, because I think without that, you're not going to achieve the full potential. So I think I would amplify on what you're saying and extend it out to the point where thinking about it in a manner that regulation, policy, as well as informational barriers induce the market to move forward in this integrative way is very important. In addition, I would argue that there are certain barriers currently that have to do with pricing, for example. The fact that we have energy suppliers that think of themselves as producing and supplying energy, which is exactly what they do. But to really induce more energy efficiency, you need to talk about ways in which you talk about providing energy services beyond just a unit of energy. And again, there are lots of issues currently with the pricing mechanism that subsidize certain types of fuels, that provide incentives to produce more and supply more energy. I think there are things that can be done there too.
Thank you. Rémi Chabrillat, vous avez mentionné, vous, Amit, Bando également, que vraiment là où on peut faire le plus d'économie énergie, c'est le bâtiment. Donc Didier ROUX, ma question, est-ce que vous avez des chiffres clés sur le bâtiment?
Also, I will speak in
English. Yes.
Let me show you and come back on the numbers that we have just seen previously. This is for Europe, not for France. But as you see, it's about the same. More because France is not the first one. More for the buildings in France. So as you see, when you divide the energy consumption in three categories, you have more or less a third, a third, a third. It's not exactly a third, as you have understood. It's more for buildings. But for transportation or for industry, you have more or less the same numbers. The next slide, and I think who is... I have nothing. Oh, yeah. The next slide shows the progression of the new buildings, the quality in terms of consumption, energy consumption of the new buildings from the old time. Old time is not so old, by the way, it's probably before 2000. And the new regulation. So this is for France now, it's what is called the thermal regulation. 2005, and the last one, it's named here BBC, which is Bâtiment Basse Consommation, Low Consumption Buildings, or the new regulation, RT 2012. As you see, the main and the most probably impressive effort is done on the heating system, which basically is going down by a factor close to 10, which obviously is good, but it's also a measurement of how bad we were in the past. And it's obviously, it has to do with the challenge with the renovation of the buildings. The second thing is that when you realize that for new buildings, the new regulation has now a number which is as low as below something for the heating, 30 or 35 kilowatt per hour per year, and per square meter, it means that obviously the new challenge is on the rest, on the appliance. So you have really to keep in mind that in terms of buildings, because as we have seen, it's 42% in Europe of the energy expenses, we need effectively to reduce everything. The last slide, yes, is just to show you the impact of and the responsibility of the construction business. Assuming that all the buildings we are living and working on, if all these buildings were at the level of the thermal regulation of 2005. I'm not even talking on the last one, 2012. I'm talking about 2005. Let's assume that all the buildings in a country like France or in Europe will be at the same level in terms of energy efficiency than what was built or is built in 2005. As you see, the arrow is showing the energy saving that we'll have. What does it mean? It means that basically, obviously, the old buildings were not taking care of energy efficiency, that's known, but it means also that this amount of energy that we could save is equivalent of all the energy which is spent in transportation or all the energy which is spent on industry. And if you think about the social impact of that, assuming that you want to save, let's say, 30% of the energy which is spent, which is more or less the size of this arrow, if you decide to stop all the industry, obviously the consequences will be huge. If you decide to stop all the transportation of people and goods, it will be obviously a big change. If you decide to just improve the quality of our buildings, even though there are some issue about it, it's obviously an improvement. It's why, basically, all the government came to the idea that the place where you have the most saving possible are effectively the buildings. And it's not because it's a question of technology and so on. It's just a question of we have been very bad in the past. Probably transportation and industry have been probably better in improving the energy efficiency, which is true. And buildings have been very late to realize how much energy we need just to keep us in an environment which is nice to have when the outside climate is changing.
So Didier, you're working on passive energy efficiency. Can you tell us what does it involve?
Okay, so there are two ways to reach this goal of decreasing the energy consumption of buildings. One way is to work on the envelope, basically to avoid to waste energy. When you eat something, you don't want this energy to go out, so you have to have something which is a good insulating envelope with air quality, with comfort, and so on, keeping something like a constant temperature inside the building with very low energy. But obviously, as we have seen for the appliance, but it's also true for the heating system, you have also an issue about regulating the way the energy is managed, basically, in your building. And this is more the work of Schneider, which is to manage the way the energy is used. For Saint-Gobain, obviously, we are more working on the envelope, trying to keep something which is as good as possible in terms of insulation systems.
So Marc, exactly. So now you're going to talk about the active energy efficiency.
Yeah, thank you, Didier, because it's exactly in the follow-up of what Didier just said. So basically what we do at Schneider Electric is measuring, monitoring, and managing the data linked to the energy consumption of our customers. Basically, so you see the little slide here where we say it's an active way, it's an active behavior, because first you have to fix the basics, and then the first thing you have to do is measure how much you consume. Guess what? This seems to be very logical, but 50% of the businesses in the world do not measure their energy consumption, right? So it really starts with this. It starts by measuring. Measuring, and after when you measure, it's about monitoring. So you are in the active phase, you do that regularly, because if you don't monitor, if you measure only once, then what's gonna happen is that you will have data, you will maybe start to do some few actions, and then after a while, human nature takes it on top of that, and it will go back to where it was before. So active monitoring of energy is something which is critical. And the third thing, what we do before giving you a practical example, is gathering data. Energy today is digital. We have the capacity with today's technology to manage those data, to gather those data, to aggregate data, and then to make the right decision. What Amit was saying is that technology is ready, and this is my second point, is that it's not a dream, what I'm going to show you in the 2 or 3 examples after that, is technology is available today. We know what we have to do. This has been shown just before by my colleagues. Technology is available. So the big challenge we have is to make it happen. Right?
So in this active energy efficiency, what exactly are the new technologies? Can you give us some examples?
I will give you just a short example because if I can have the next slide, it's just about, businesses like ours, we sell solutions to our customers, but what we want also to do is to walk the talk, to apply the technology in our premises, in our factories, in order to show that it works. So this is the headquarters of Schneider Electric in Paris, and we have been reducing over the last 3 years by a factor 4 our energy consumption. It's a building which has been built in the year 2000, so which has not the new technology of companies like Saint-Gobain, but we have managed to reduce through monitoring, through measuring the consumption heavily. So it means that we have the return of investment of 5 years, which is pretty much what we sell to our customers. So normally businesses are signing orders with us about 3 to 4 years. We've put a little bit more of our technology in order to have a showcase. And again, its measurement point is giving the right information to know where people consume, to benchmark, and then to have an energy manager, so someone who does actions on a daily, on a weekly, on a monthly basis. So this is possible. It happens in a lot of buildings. Again, buildings, I agree, buildings are 40% of the consumption, but it happens in the same way in industries or in data centers or in transportation. Again, so my message here is this is possible. This is with the technology of today. What is very important also is the power of standardization of standards, of course, because we have to measure in an homogeneous way, and the power of standards are very important. So there are standards at the French level, at the European level, and this is the first building ISO 50001, which is an ISO standard, which measures the steps you do in terms of energy efficiency. Okay. In terms of new technology, rapidly, and if I can get the next slide, I'll be moving you through two things, which are smart grid and demand response, which have been already introduced by my colleagues. So smart grid, also the same message, smart grid is a reality. Smart grid is putting together smart supply and smart users, smart demand, with something which is a game changer, which is a very strong game changer for the energy grid, which is renewable and electrical vehicle. So these are two game changers and will change the way we are managing our grid. Just few things, know that there will be as much investment in the 20, 30 years to come in the electrical grid that there has been since the creation of the grid. The Germans just announced 20 billion euro investment on their grids because they produce with renewable energy in the North Sea and their industrial consumption in the South. It will be the same in France. It's the same in the US. So this is reality. And again, it's the same, is managing data and aggregating data and being able to visualize where is the consumption, where people use energy in order to better manage. Because what we believe, all the experts, is that if you give to people the tool to manage, if you give them tools which are simple, which are linked to their business, then they are able to reduce energy consumption by 20, 30%, which is what we see every day in our business. 30% with a return of investment of 3 years to 4 years is something which is achievable now with the right technology. The same concept, little bit inside the smart grid with what we call demand response, which is in fact, if I can have the next slide, please. Yeah, so it's the capacity when you have peak consumption, so in summertime in certain areas or in wintertime, let's say in France, it's to have the possibility smart users are bringing their capacity to reduce energy in 2 to 3 days to the suppliers of energy. And instead of putting on new capacities, then we use the capacity of energy and energy efficiency that every industry, every building has. So this is a kind of balance between extra supply at one moment of the time and potential of energy efficiency. And this works because this works in France with a company called Energy Pool, which has been doing that during the heavy winter that we had in 2001 and 2002. So that's the new technology being available to drive energy efficiency.
Thank you, Marc. So we have heard about new technologies in the active energy efficiency. Now let's come back to passive energy efficiency. What are the new technologies in this domain, Didier?
Thermal energy propagates two ways. The first way is radiatives, which means that any material which is at a given temperature radiates, usually infrared, depending on the temperature, infrared radiation. And obviously, this radiation goes away, and it's a part of the energy which is lost. And the other way is direct conduction. I mean, the energy is something that can go, the thermal energy can go through a material just by increasing the movement of the atoms and so on. So it's a conduction through the material. And a typical insulating material is basically air. Air with a way to stop the radiation and with a way to keep air not moving. Otherwise you get convection, and convection is a very efficient way to transport heat from one side to the other. So you have to have more or less air which is immobilized. And a typical material to do that is a very light material, porous material, with air inside, which cannot move. And in this case, you have a classical insulating material. To improve that, and to go beyond these classical materials, it's a little bit difficult. And there are not so many ways to do it. In fact, we have two ways. One way is to make the pores of this material, the pores of this material, so small that the conductivity of the air is going down. And this is typically what happens when the pores are below 1 micron or a few hundred of nanometers. And in this case, the conductivity of the air goes down, and you can decrease quite a lot the conductivity of the material once you have cut the radiation. The second way, if I can have the next slide, please, is to remove the air, basically to have a vacuum. You can always replace by another gas, which is better, what happens from time to time, but the best way is to remove all the air and to have a material where there is no gas inside. It's called the vacuum insulating panels. And that's basically the two ways you can improve insulating materials. And there are not so many ways. And obviously, when you do this or this one way or the other, and the solution exists, but they are not easily adaptable to buildings because of the cost and because of the way these systems are built. So we need research, we need innovation in this area to bring this new solution in the buildings, and this is specifically true for insulating old buildings where renovation, when we want to renovate all buildings, because in this case there are obviously solutions which have to be adapted to these old buildings, especially in big cities. Okay.
Yeah, so I think everything what we just heard is very interesting, but I think, Rémi, it has a cost. So how will you incentivize people to renovate the living places?
That's a question, and that's it concerns a lot of people. In fact, when I talked some minutes ago about the reduction that we could anticipate for the next 20 years, that meant that for buildings, 500,000 flats or houses will have to be renovated every year. So we have to convince 500,000 people to do this. And two things. First, information. And more than simple information, it isn't sufficient to say you must, you need, you can improve your house, but it's important to tell people how they can do it. They can do this. So in France, we developed a network of energy counseling, free, independent, in fact, financed by ADEME and local authorities, which it's called les espaces info énergie, energy information spaces. And it's not sufficient because it's about 400 counselors on the whole country, and I think we counseled last year 150,000 people. So we're not to the level that we intend to attain, but that's something necessary. The second part is obviously to help people to finance the investments that will be necessary. Fortunately or unfortunately, it will be economically interesting on the long way, because the increasing of the cost of energy will, in fact, make a certain rentability possible. But it's on the long term, and everyone cannot today invest and find the money that's necessary right now. So the interesting point can be to find third parties financing, and that's an interesting example in the UK. It's the Green Deal process. It's interesting in our point of view because there's a loan that is made to improve a building, a house or a flat, and the loan isn't made, in fact, to the owner, but the loan is made to the house. And when you sell, when the owner moves, the loan is passed to the following. And it increases the length of the remboursement. See, the payback is longer, and then it's easier to find an economic interest to it. Other possibilities are some local authorities in France are working on third-party financing, more or less supported by local authorities, local energy efficiency public services. We think those are interesting possibilities to help and to pass this difficult moment, which is how to finance improvement.
Okay, Marc would like to make a comment. Short.
Just short on what Rémi just said. I mean, we see also those financing on other types of businesses in other countries, in the US, in the north of Europe. Sweden is really heading the pack here, where the concept is the following: is a third-party agreement between, let's say, a university or a city, a technology provider like Schneider Electric, and a financing world. I mean, the banking system must be in, and it's the capacity to extract the energy efficiency which is in the building during a longer period, and to finance renewal of assets. So this business
France,
model.
Could we be inspired by these kind of financing?
Of course, there are discussions at the European Union at this level in order to apply this model, because we see that businesses and often governments don't have money to invest, but this capacity to extract energy efficiency, which is resident, to monetize energy efficiency, is an excellent business model to renew assets, but also, as we see in Sweden, since for instance, for schools are managed by towns, and we see a lot of things we can do. We can even pay some part of the cost with energy efficiency capabilities. So it's a very interesting business model applied outside of residential in other countries in Europe and in the world.
Okay, Didier, let's come back to other technologies. Now let's talk about new technologies of new buildings in particular.
Yeah, let me try to fill up the gap between what we talked about previously, mainly between a passive and active way of managing energy. I want just to show you two examples. The first one is, and may I have the next slide, please? The first one is on materials. And these materials are called phase change materials, and it's a way to store energy. In fact, when you probably all know that when you go from one phase to the other, from solid to liquid or from liquid to vapor, material, you have to bring energy to this material. Energy, obviously, to change the temperature, but not only energy to change the way the matter is organized. And this energy, the beauty of it is that you can recover this energy on the way back. So when you go from vapor to liquid or liquid to solid, you get back this energy which has been stored in the phase transition. Basically, it's the condensation, the heat condensation that you have in a typical classical heater by gas is an example of that. And this energy that you get can store some heat and we may think, and it's already, these are technology which are coming on the market, where during, for example, a day with a lot of sun, you can store some energy in melting a material from one phase to the other, and then during the night, the material will go back from, let's say, liquid to solid, and will give you back this energy. And there are systems like that which are more active and not just passive. Another example is on glazing, on glass. Next slide. So it's electrochromic glazing. Electrochromic is a way to change the transparency of the glazing, the transparency of the glass. If we can have the next slide, please. Next slide. Okay. This is an example of when it's opaque, or it's more less transparent. And if I can have the movie, I will explain that to you a little bit better. So the movie that you will see is a simulation of a building in Madrid. So you are in the summer, it's very hot, you get a lot of sun through the windows, you are at your office trying to work, and you have two problems. First, you have too much light, and also, obviously, the air conditioning system has to be strongly efficient to compensate. And you can change the transparency of your windows locally just to make sure that you get enough light to work, but also you save energy from the air conditioning system. And obviously, it's an active way in the sense that the change of color, the change of transparency of your glazing is something that you decide with some electricity and obviously a system that will control this. And by the way, it's one of the examples of technology that we are working with Schneider because it's really a mixing. So, as you see, there is effectively a continuous path between active and passive, and again, we have to do both. Another example that I would like to show you, because I do believe that this might be very important also for you, because you are a gas producer, it's something which is very well known, but not yet industrial, which is a solid oxide fuel cell. What is a fuel cell? A fuel cell is a system where basically you burn gas, classically. So you know when you burn gas, it's a chemical reaction. You go from a gas with oxygen, and you get the oxidation of the carbon through an oxidation chemical reaction. And this has been known for a long time, and you get heat out of that. But you get heat, but it's also, during the chemical process, you have exchange of electrons. And this is known from the 19th century, that if you do that in a separate compartment, you can get these electrons and you can move these electrons through a wire and produce electricity, basically. So it's like a battery. It's a way to produce electricity and heat. The beauty of that is that it's a very efficient way to produce electricity. In fact, it's much more efficient than the classical way, which will be to burn gas in a turbine with a productivity of around 30%. In this case, you can get easily 50% of productivity, which is better than the best system we have. And then you can also recover it, and in this case, you are much closer to 80–90% of the recovery. And for buildings, this may be important because basically the idea would be that you may have something that will generate hot water for your building at the same time that it will generate electricity, starting with gas. So it's very attractive, but up to now, even so there are many prototypes of this kind of technology, there is no real product on the market because two reasons. The first one is too expensive. And the second, it's not very reliable. We have a problem of cycling and changing because all these systems are running at 800 degrees Celsius, which is high temperature, and when you stop and go, the materials, which are basically ceramics, may have problems. We do believe, however, that there are huge progress in this matter, and that we will start to see, the Japanese are in advance probably on these technologies, but we will see in the future this kind of solid oxide fuel cell that will be at a reasonable price and will be reliable. And this can be effectively very interesting because it's a good way to produce electricity, produce heat, and save a little bit more the gas that we will need for the future.
So Marc, when you combine active and passive energy efficiency equipment, that turns out to be a very important capex for industrial sites. Are there any innovative business models?
The innovative we were talking just before, but what is very interesting is that you have different possibilities. Either you have the traditional business model, the traditional return on investment, and today with what has been presented by my colleague from Saint-Gobain and what we provide ourselves, is you can easily reduce 30 to 40% in a return of investment of 3 years with the same comfort and the same efficiency of your processes, which is important. Again, the message is not to reduce energy, but it's to reduce energy and keep the same level of comfort in buildings, so keep the same level of efficiency for our industries. That's the first thing. And we have innovative business model where we co-finance with the potential of energy savings over a longer period, and we manage with that to implement strong asset management renewal with a performance contracting business model, which is what we use in the US and in different parts of Europe already. So it's flexible, but always it drives a very strong energy saving. So again, technology is ready, business models are there, and it's up to us to make it happen, because what my colleague from Italy was saying just before is it's a call for action. I mean, we need to be better in this field. We need to be energy efficient, and this is not for the next 20, 30 or 40 years, it's right now, because we have commitment and we took commitment in this field.
What do you think about industrial sites? Where can you be energy efficient? Which part?
There are two main, I think, can we have the slide if it's possible? Two main ways of consuming energy in industry. There's the process, and that's the first thing that you think, but the utilities represent 30% of energy consumption in the industry, and there's a very strong energy saving potential. We can estimate it around 40%. I mean, utilities, it's heating the buildings, it's motors that will drive transportation or a lot of things in every kind of industry. It's heat recovery, air conditioning, and so on. And this can represent, as I said, a very strong energy saving potential. I must mention that Total and the ADEME have worked together on this field of industrial utilities since 2009, and we finance together research projects on mainly utilities or very transverse process, and we finance together. I think Jean-Pierre Gourlia will tell this more precisely than me, but I think about 35 projects in the last 4 years, and to say the main possibilities, we mobilized something about 100 million euros about this. Second slide, if you please, is about energy saving potentials in process. They are important too, and what seemed interesting to tell today is that a part of it, more or less half of these energy saving potentials, is on disruptive technologies, things that we don't use today or that are emerging as for heat recovery, organic ranking cycles. We finance one project with Total, and it's the first in France, or in what you call the 3D printings. But also there are a lot of possibilities in recycling energy, in waste reusal, in heat recovery, optimization, and this can, on existing technologies, represent half of the energy saving potentials in this. So it's possible, it's technically available. After that, we go back to what Marc was telling about how to finance this, but it's possible.
So, Rémi, we've just seen that there are really a lot of technologies are usable now in the near horizon. What are the factors you think that could reduce or accelerate the implementation of energy efficiency?
Probably regulation. And
can you tell a bit more about your
yeah,
regulation, national and international level?
On building, as we know, as we already talked about, there are two things. New construction, and for the new construction, there is regulation in France and in other countries that applies to the level of consumption of the new buildings. I think it's Didier who showed us things a few minutes ago. An ancient building consumes about 250 kilowatts per square meter per year, only for heating. The new regulation asks that buildings won't consume more than 50. This is quite easy. It's easy to tell. After, you have to help the building industry to evolve. There's a lot of formation. People have to be trained, but this can be done more or less easily. For renovation, for existing buildings, we don't have by now regulation, and we think that it's a step that will have to be done. It's an obligation to renovate residential lodgings, maybe when you sell them. It's a possibility. About industry, there are already in Europe the quote system. There are also regulations through the IPCC circular. We won't talk too much about it, but with what's interesting is that it's not only a regulation that say you must do, but that shows ways to do it, and it's we call the best references system. It's the BREF. For transportation, which is another huge field, there are things. First, the emission of vehicles are more and more regulated, and then there are things that are tested all around Europe, and in France, it's low emission zones. The ZAPA. The term is quite strange in France, but it doesn't matter.
Zone d'action prioritaire.
Prioritaire pour l'air. All the things that it's working on large areas on reducing. In fact, the first aim is the pollution, but as a large part of it is caused by fuel combustion. Okay. In fact, it's an energy-saving measure.
Thank you. My last question is for you, Amit Bando. It's about the initial investment, which is also a key factor in driving high-impact energy efficiency. What can you tell about this, please?
Yeah, I think a lot of the points made really refer to that. There's, as has been suggested, there is technology that's available, that has been obviously demonstrated. There are new business models. I think the key here is that there's a perception that energy efficiency investments are very costly because of the long payback periods. Again, the new business models that have come up are trying to address that. But it's to scale it up to a point where instead of them being just case studies, we look at them as bigger and bigger scaled up investments. So this gives you an idea that if you look at just between the 2 years that we have put up there, 2010 and 2011, energy efficiency investments have gone up from roughly 3.7 billion to 10.1 billion. Well, so there's something happening here. It's still not there where it's moving up the ladder, if you may, where wind, solar, and biofuel, others are higher. Now, there's an inherent problem. That is because, as was just explained, energy efficiency is not viewed as a sector. So you don't see a wind farm going up or a bunch of solar panels going up. So you really have a problem with investments being spread out over very many industries, very many sectors, very many technologies. There are differences between different regions of a country, let alone between countries. So that's where you have the barriers. So it's an informational barrier. It's an awareness barrier. It's a consumer behavior barrier. These are the ones that we've talked about, and these new business models are trying to overcome them. And perhaps another way of looking at it at the next slide and is to really emphasize the co-benefits. This was mentioned in the first session today. The fact is that if you just look at energy efficiency, yes, the cost may be high, but if you really look at all of the co-benefits, higher property values, reduced unwanted mobility through better transportation planning, things such as health costs, productivity improvements, these are the kinds of things that need to be factored in. And dare I say that in the financial models, in the investment models, these are not totally factored in. And these are some of the soft issues that need to go in, besides just saying, oh, we have a great technology that'll take care of the problem. And there's also an inherent tendency to go for supply-side solutions. These are demand solutions. So we need to, again, move away to a paradigm where maybe with better price structures, currently we have a lot of financial price subsidies, if you may, that subsidize fossil fuels. Those need to be rationalized. So there is a role there for government. There's a role that will allow a better playing field such that these investments are, instead of being perceived as being very costly, are in fact shown to be quite doable.
So thank you very much. So it's time for your questions now. And I hand over to a reference advisor who is in the audience and who would like to challenge our guest speakers with some questions. Jean-Paul Gourlia, Jean-Paul, could you please stand up? He's in the foundation team of the Energy Efficiency Excellence Institute in Paris-Saclay, a French super campus, and he's a former senior executive of Total. So can you tell us about your question, please?
Oui, en fait, je vais parler français parce que je réfléchis mieux en français qu'en anglais. Bon, en vous écoutant, moi, je suis un peu mal à l'aise parce qu'on indique qu'on pour atteindre les objectifs en termes de stabilisation de changement climatique, il y aura 44% des efforts en termes d'efficacité énergétique. Ailleurs, on me dit que les technologies sont prêtes. Et je n'ai pas une vision aussi optimiste. Alors j'ai un certain nombre de questions parce que je crois qu'on a oublié peut-être un certain nombre de barrières et oublié peut-être un concept de base à mes yeux, c'est la notion de système. Alors en ce qui concerne les barrières, que je vais prendre l'exemple, c'est le smart grid. Le smart grid est vu très souvent comme un moyen d'optimiser les moyens de production en énergie, mais rarement vu comme un moyen d'optimisation locale de sous-systèmes énergétiques. Et pourtant, par exemple, surtout en France, il y a une barrière énorme, c'est la réglementation qui empêche de faire des échanges d'énergie entre clients. Donc, ma première question, que faire pour combattre cette barrière réglementaire? La deuxième remarque...
Peut-être on va commencer déjà avec cette question-là.
I will take this question. You are perfectly right. I think that you say that technology exists, but there are a lot of barriers. But I think that I believe that the future of grids will not be of super big grids. It will be a lot of regional systems where a lot of exchange, people will at the same hand produce energy and consume energy, and this is where we have to work with the different governments in order to adapt. We need to adapt the regulations here. So it's not about only motivation of users and business models and etc. But the standard and the regulation piece is absolutely fundamental to make everyone working together. It's not here when we look at this issue and this challenge that we have together, it's really a community of work. It's community of work between businesses, between inside the businesses, between industrial people, influencers, and the banking system, which is not, which should be much more involved, and it should be also with governments and with everyone who can influence. So it's really a working together, and you are perfectly right that we have to adapt, especially in France and in other countries, the regulation on this field.
Voilà, une deuxième question, ou commentaire courte.
Moi, j'en avais plusieurs, alors, parce que j'ai que deux, je vais prendre la dernière. En ce qui concerne l'industrie, on nous a présenté des gains potentiels, comme d'études sereines, de 40% de gains énergétiques sur le secteur industriel, et là, j'en reste ébahi. L'industrie, au moins l'industrie intensive, a déjà réalisé 40% au XXe siècle, si je peux parler de cette manière, et depuis 10 ans, ça se stabilise. Et je crois qu'il n'y a pas de miracle, c'est que les principaux gisements ont déjà été épuisés, et que si on veut continuer à progresser, ça passe par l'innovation. L'innovation en termes technologiques, donc pour reprendre quelque chose que j'ai vu sur l'écran, donc aussi probablement avec de nouveaux paradigmes en termes scientifiques. Donc c'est un enjeu extraordinaire sur lequel on travaille peut-être pas assez. Et puis la deuxième notion qui n'est pas apparue, c'est la notion de système. Je prends un exemple, si vous construisez une maison basse consommation à 20 km de votre lieu de travail et que vous êtes obligé de faire les trajets en voiture, le bilan énergétique global est équilibré. Donc, une autre manière de voir, c'est qu'il y a un certain nombre de bassins industriels où chaque industrie travaille séparément, alors qu'il pourrait y avoir la notion de smart industry, comme on parle de smart grid pour le domestique. Et là encore, c'est un domaine dans lequel on ne travaille pas.
Un commentaire?
This one's for me, I think. But he knows it. First, when about the 40%, that's very impressive, and I admit that it's not at the hand. It was a technical potential and not, and it first was a technical potential and not on process, Jean-Paul. It was on utilities. And you are right. The industry has made a lot of effort and a lot of progress on the last 40 years since the first choc pétrolier, since 1973. Industry has made a lot of progress, but a lot have been done on process, and maybe not. I think we think that there are more possibilities on utilities, on the things that you don't look every day when you're in industry. You look at your process because it's what it's your business, and you're very precise on this. But on heat recovery, on motors, Schneider could say this. There's a lot of things to do on electric motors, motorization. There are still things that we can win. But remember, in the beginning, when I talk about our reflections, what we're thinking for 2030, on industry, we only we think to only 10% of energy saving globally, and the main objective was 20%. So industry is under this global objective. The second thing was, and I'll be quick. And
la notion de smart industry.
Yeah, that's there's I don't know if it's a beautiful name, but écologie industrielle, industrial ecology. That's something we try to work on it, and we made we tried to make projects emerge through investissement d'avenir. And there's a program in this, and we recently received some propositions that are going to be financed on industrial ecology.
Merci beaucoup, Monsieur Gourlia. Thank you. Yeah, we can applaud them. Thank you very much for coming.